Hi, welcome to Catia training. So before going to Catia and what is Catia, first let's have a brief idea of what is CAD and what is the importance of CAD. CAD is originally includes techniques that uses computers in design process including drafting, stress analysis, motion analysis. But over the 35 years, CAD has come to refer more specifically to computer aided design and drafting. Previously, all the drawings and all the designs and everything and all the drawings were used to be done manually. So they started and all the calculations used to be done manually and there used to be errors in that. So they started using computers to for better accuracy and also to make the process easy for user friendly, like for the who are doing it, to make it easy and friendly. They started introducing computers, and that is the basic start of the CAD. So over the last 35 years it has changed to such an extent that CAD has become computer aided design, where it is morely an electronic tool that will enable you to make new and quick and accurate designs with use of a computer. Using it might be 2D. It started with being 2D and 3D. Computer drawings are neat, clean, highly presentable, and can be modified easily. With CAD, parts or components can be modeled, visualized, revised, and improved on the computer screen before any engineering drawings have been created. A CAD model is a computer representation of an object or a part. It contains all of the design information, including geometry, dimensions, tolerances, materials, and manufacturing information. CAD models replace the paper blueprints and engineering drawings. The simplest model used in a CAD is a 2D model. 2D is just a 2D representation. A 3D is it has all the three dimensions, height, width, and this thing. So a CAD model, the basically a CAD model is something like whatever the real part you have, you create a virtual part of that. So to check everything before going for the actual production, so that you are happy with the final product while doing the manufacturing itself in the manufacturing. So you don't have to do the all the uh, error all the errors, and you don't have to need to have the material wastage and everything. The model is essentially the computer graphics equivalent to the orthographic projection. A 3D model is the most general model used in the CAD software. The model is equivalent to the isometric view. Two basic types of 3D models are wireframe and surface models. Wireframe models are nothing but that consists of all the outer edges without with all the like just only having it's just like the skeleton, only having all the outer edges being visible. That's it, and without having any surfaces or any opaque surfaces. Okay, in a 3D wireframe model, only the edges of the object are represented. 3D surface represents the define the objects in terms of surfaces. The surfaces are just planes or shells. Okay, they don't have any properties, any thickness, or any mass. Solid modeling. The current state of art in CAD is the most sophisticated method of representing an object. Unlike wireframe or surfaces, the solid model represents an object in a virtual environment just as it exists in reality, having volume as well as surfaces and edges. In this way, the interior object is represented in model as well as outer surfaces. So, like you will, the object which you create in the virtually, that has all the properties and that has all the proper information. Okay, all the proper volume, thickness, mass properties, densities. Okay, and how it cuts and how it looks when you take a cross section of it. So you can see all the information inside this. And why CAD? What is the necessity for using a CAD? A CAD software allows the designer to create and manipulate a shape interactively and store it. Okay, so what are the advantages of CAD? CAD saves you money and time. Okay, so previously when they are everything was done manually, so they used to try do creating that. They used to create one design and make the improvements and everything and get it and make up improvements, and there used to be lot of trial and errors and revisions, and there used to be lot of wastage of material and money and labor hours. But if you use CAD, so you can get the uh, desired proper design in the design stage itself, so that you can have a better idea before going to the manufacturing. It eliminates prototype model building to prove the designs. Uh, because if you want to create one model, you just create one model and you try to improve that design previously. But now you can check, you can do all the stress analysis and everything. So before making the actual even the prototype or the uh, pilot build, you already have all the information, how most of the information how it would behave in the real life. It allows designers to determine costs and test such variables such as stress, tolerances, product variability, interchangeability, and serviceability. So when you know the complete product and when you know how does it look and everything, so you will have a better idea of how much stress it can bear, how much tolerances you need for this design, how much tolerances does it take for this current design and current dimensions. So you can have all the information, and you will have interchangeability, like uh, if you are replacing this product, like if you are designing a new product to replace some other product, you can check the interchangeability, how whether the how it can fit in that place, whether there are any issues and all. Okay, so you have a better view, and you can check on the issues. And low cost of design, because you don't need to actually use material to create a product to get to know about it. It is a low cost because everything is virtual and you can check in online itself. Eliminates manual drafting completely. In manual drafting, it is prone to lot of errors, and if these errored or flawed drawings go to manufacturing, it will also create lot of issues. Okay, so that's why it eliminates this manual drafting completely. So you can do, because you can get accurate and perfect computer drafted drawings, easy to manipulate. So if you want to if you have a proper design, if you want to update any design and all, you don't need to do update everywhere. You just need to for example, if you want to increase some length, you can just increase in one length, and it will show, and it will automatically reflect. And if you want to do any designs also, you can easily track everything. You can update and do easily. Makes review of numerous options in design. So here you won't be having any errors, and it is easy to update. It makes review of numerous options and designs possible before final commitments are made. Like, since you can easily manipulate the design, so you can get multiple versions and multiple variants. You can design multiple variants easily, not like you don't need to recreate all the views and everything manually by with manual drafting and all. You can just have multiple options by just doing small updations to your design, so that you can provide better options and more number of options to with all the stakeholders, so you can before the final commitments are done. Faster development, better products, and accurate flow of information to other departments. Since in CAD you eliminate a lot of manual work and everything is computer design, and in computer aided design works, you can get things done completely. You can get better products, and you can you when you can use this product lifecycle management tool, you can have a better communication to other departments and provide, you can get a proper products. Product cost can be determined at the design stage itself. Product, because in the design stage itself, you can the complete product, you can actually visualize the complete product how it looks, so you can have a better planning of serviceability and all. So you can check how much what material is used, how much material is required, how much volume is there, and you can also check how much of serviceability, how much time it is going to take. With that, you can also calculate the assembling time, manufacturing time, process planning time, so you can have a better information in the design stage itself. CAD software allows the designer to access critical areas of the actual design which are hard to access and helps for better study. For example, if you take a engine inside the cylinder, it is generally hard to see, to access the area and visualize how it looks inside the cylinder from the piston. Even like if the piston is in closed position, it is hard to check and visualize how it looks from the piston closed from the piston surface to the valves. But for example, but here in CAD you can actually zoom it and you can view all those areas and also all those places which are actually hard to access through hand and everything, so you can have a better understanding and you can update your designs accordingly. There are so many CAD softwares like Creo, UGNX, Catia, Solid Edge, AutoCAD, SolidWorks, and all these things. We are dealing with Catia in this. So let's look into how a Catia software looks.